So nextly, please allow me to introduce Mr. Antonio Barto from Aplitop to introduce you the part of the Aplitop and how will we work the MTT with ZWCAD to satisfy the civil engineering works. So Mr. Antonio Barto, it's my pleasure to have you here.
Hello, Mr. Michael. Thank you for introducing myself. Okay, I'm going to share my screen. Okay.
Yes, please.
I'm going to speak about. The first of all, I'm going to introduce myself. I am Antonio Pardo, survey engineer from Aplitop, from the support team Aplitop, and I'm speaking about the workflow that the survey we need to follow in our question tags. For example, under the Aplitop ecosystem. In this graphical, we can see a cycle where we can find a reality, a natural terrain that we need to measure. Okay, we can use our GNSS devices that we can control with the TcpGPS, or maybe we can use the data from the laser scanner, LiDAR sensor, or photogrammetry, something like that, that we can control with the TcP PointCloud editor. And both of them are developed by Aplitop. Okay, with this information, we can process and import ZWCAD 2024 by TcpMDT. TcpMDT allows us to process the information, the data, and create a mapping or cartography, something like that, to analyze them, to design some solution in some problem in the reality, to create the civil survey, the civil survey engineer, okay, civil project engineer, and show that when we finish, we can take out this project to modify the terrain. In this example, we are going to make a survey of this street. Okay, we are going to take all the data, and the first of all is to running the TcpGPS to take the point in the field. We are going to connect our device, our smartphone, by Bluetooth with the GNSS, okay, by Bluetooth, and we are going to choose the working mode. In this case, we are going to choose the rover station by NA-trip protocol, okay. I'm going to use the data, the connection of the internet by internet from our smartphone, or maybe by our SIM card or something like that. We can use we need to create a project where we need to type the name of the project, okay. And very important thing is to choose a right global system coordinate to organize the system reference. At the end, we are going to make a survey of this strip, okay? We go to start the application, and in this example is a question task that we are going to take point by point. It's a entity of the field that represent the relief, like a brick line, like a curbstone line, different wall side, different line in the strip, or singular point like wheels or lamp port, trees, etc. To help us, TcpGPS allow us to use a code database where we can find a lot of codes that you use in the work. Okay, so not only that, we can type a new code in the real time. If we need, for example, the vertical signal or something like that, we can make up the different code. We can use. We also use a code prefix that allow us to follow several lines, the similar characteristic by number, or maybe we can use a multi-code in only one code, in only one point. Okay, at the end, the objective is to take all point in and describe by graphically all the natural terrain. We have several graphical screen. For example, we have this numerical screen where we can find the code database, or we can find the different options, or we can the graphical screen where we can see and verify which point we are take. Okay, during we are missing. Another important thing is TcpGPS allows us the layer manager where we can control the different visualization of the layer. For example, we can visualize the point in different size with different size, different color, or something like that. We can use a different remap the community for street view, street map, survey map, or ortho image, or the background, another ortho image. We can control the color of the point, the shape, the size of the text. We can hide, or we can visualize different layers, or we can import by layer different format like DGF, or maybe GMES or ZIP file, something like that. Okay. At the end, we are going to create to export the information that we took in the field, and we are going to save in one folder in our smartphone, or maybe we can share in the real time that information by mail, by drive, or something like that. In this case, we are going to share one list of the point with a structure, fixed structure, and we are going to drive to save in the drive, or maybe if we want by mail or something like that. Another thing, we can export several formats like MDT, GML, or DGF, is the case in this question, where we can manage, we can control the scale or the text size. Okay, we export the information and we are going to treat to process in ZWCAD by MDT. ZWCAD 2024. Okay, open ZWCAD 2024, and we are going to open in the first step the DGF. Okay, when we open this DGF file, we can see that there are the brick line that we took in the field directly. Only brick line, text, or points from the CAD like this. Okay, and you can work perfectly because our entity organized by layer, something like that. But you can, if you don't use MDT, you can work with this information. Okay, but right now we are going to import the list of the point to repeat the operation to check the difference. Okay, so I'm unzip the file that I create with TcpGPS. I'm going to import the point. MDT has down a vertical menu, or maybe a ribbon menu, where we can find easy all the commands. And right now we are going to import the list of the point, choose the right structure. Okay, I think the most important thing is the representation of the point and draw from codes. Choose the code database, similar as the TcpGPS, to translate the code and the way of the representation, and draw automatically all entity in the draw in some seconds. When we import, MDT create a legend to allow us to interpret the map, okay, and show all the brick line that we took in the field, or maybe the punctual entity that we took, for example, lamp strip or wheel or something like that. Any entity are drawing in the map. We have a control visualization to manage the control of the point, to hide the different attributes of the point, or we can hide the different entity like a surface, like a contour, profile, or something like that. Draw each point in right coordinate in right scale and right orientation. If we took several points, we can change the scale of the point, or we can change the color of the attribute, or maybe we can change the localization of each attribute according with the level of this point or something like that. It's many tools allow us to work in MDT. MDT offers us also to many commands to editing of the brick line. For example, in this case, we are going to make up the top of the curve, because we took in the field the bottom of the curve, and we are going to make a 3D parallel of this line. Okay, there is several points, several tools to make different surveys. Right now we are going to make a surface to triangulate all the points according with the brick line. And here is the result of our surface. Right now we are going to draw the contour line. I'm going to make a key distance. I'm going to use a palette of color at a glance, see the lowest or highest area. Okay, we can use several instructions. For example, like a quick profile, where we can find or we can measure some detail. For example, we can make a dimension for the car park in this case. Okay, here is exaggerate 5 times the crossfire. Okay. We can use several tools like a water drop, okay, where we can find the minimal path to solve when it's raining, for example, to locate the path of the raining. Okay, at the end we need to use all these tools to create a cartography, a mapping like this. Okay, that we are going to analyze, to work, to design, or something like that. In this case, we are going to import one horizontal alignment. MDT offers us a lot of command to create a horizontal or vertical alignment, okay, to analyze our surfaces or combine information, okay. And here is, we are going to make a cross section to cut the surface that beyond the take, okay. We are going to make a cross section of this. Okay, choose the interval, choose the width brand, and we are going to make choose the sheet in A3, for example. This is a sample of the cross section, and here is one example of the station 40, the distance, the natural terrain, etc. So we can mix all the information with, for example, a laser scanner, okay, because ZWCAD allows us import PointCloud, okay? But we are going to attach this PointCloud, okay? If we can check how fix our survey work in the PointCloud, okay? This PointCloud we can visualize with ZWCAD. It's very good option that offers us. MDT allows us to work with this information. For example, we can create a surface from this information using one category of this data. For example, we are going to use the ground category. We are going to triangulate only the point that is a ground category. Okay, select the area of the work, okay, and triangulate all of this point. We can see or compare both surfaces, the surface from the survey work and the LiDAR scanner, okay. Here is the result. I'm going to draw the contour line in different layers, okay, with the same equidistance, and here is. I'm going to hide the point cloud, and here is, okay. Change the color of the layer of the point cloud to check the difference, and here is. There is some difference. It's not enough, but the difference is due to the precision of the accuracy of our data. No, there are some difference in the surveys and the laser scanner, also LiDAR sensor. And right now, we are going to create a cross section for both surface at the same time. I'm going to cut the same in the same vision. I'm going to open with the cross section editor. And here it is. We can check how we can expand our survey in the border out to complete our work in those areas where we don't have information for preliminary project or something like that. Okay, are very similar, and there are some difference due to the density of the point. Okay, and right now we are going to use the webmap services to import one ortho image. Okay, select the right system, global system coordinate, and specify the Windows area. Okay, specify the Windows area. Later, I'm going to choose the resolution of the image in the server that offer us in the web. Download the map. Here it is. Okay. Right now, to explain that, we can merge both surfaces in only one. We can choose the survey work. We are going to include the LiDAR scanner to make a big surface with both surfaces. Okay, here is. We are going to make a color for this surface with the ortho image, and we are going to mapping that's all the triangular with this image. And right now we are going to make a virtual tour of the final surfaces with the virtual reality. Okay, and here is the result. This all surfaces, one surfaces with both surfaces. And here is. If we make a cross profile, we can check the difference. Only one surface with all the information. And here is. We have the river on the left, the street from our survey work, and the lagoon from the LiDAR sensor. Okay, the point cloud information. Okay, and it's very well. So in this tag, in this step, we are going to attach more information from the point cloud. We are going to attach a high density point from the manual laser scanner by SLAM technology, and here is a new point cloud more accurate with a very big density. I think is 40 million of points in only this area relative to the street. Okay, we can see the difference, and we can check that there are some far away, the point of the survey work is not adjusted exactly with the curve. For example, we need to edit that brick line where we can use ZWCAD to make this, but the tree or some information not allow very good, allow to see very good the brick line, because there are some noise, a lot of noise, something like that. For that reason, we are going to use or to introduce our application TCP PointCloud editor. And this right now we are going to import both PointCloud. We are going to see the difference of work with this application exclusively for PointCloud. For example, we can see both PointCloud by color, each PointCloud by color, or the elevation map, or the real color for each point cloud, the map of density, or by category, que is a very good thing for each point cloud, because we can classify the information by category. Okay, as we can see the point if you use EDL, because it's a representation of the point where you use like a shadow around the point. Is very useful or very wonderful to see the point easy, and we can see the difference between ZWCAD. Is very, very good, but we have a lot of tools to manage that point cloud. Right now, we are going to make a simple exercise to classify to make a different category in this point cloud. For example, we're going to make a selection, manual selection, to change the category. Make a selection, choose the right category, building, okay, and then we accept the category. If I show by property, by category, we can see the difference and before. Okay, we can repeat the operation. For example, right now in this tower, we are going to make a selection for this tower, but there are a lot of information. So we're going to make isolate the tower. So we are going to make a filter in this tower to make a good selection. Okay, filter, and the tower here is alone. Here is make the similar or maybe a manual selection by polyline. Select the right point that we want and make a selection. Okay, change right now. Change the category. Choose the category, the tower, the transmission tower. Accept the transmission tower category. Here is. It's changed. Restore the point cloud, and here is world the point cloud. Okay. At the end, we need to find one point of view to make a manual selection by polygon, like this. The cable, we make the selection and change the category. Okay. If we hide the different category, we can clean the graphical screen to make to continue make the different selection. So this is way a bit manual, but we can TCP point cloud editor offer us a process automatically. Like for example, if we use a model. For example, right now we are going to use the model that you create in MDT and ZWCAD, and we are going to convert and grid information. Okay, we are going to visualize better. Here is, and with this model, we are going to make a selection for all the points that are minimum 50 centimeters from this model. For example, we choose the geometric selection by model, make 50 centimeters from the grid, and make the selection, apply, and here is. Is a right selection of the point that those of this point we could set that they are a ground category. Change the category, and here is. If I show by category, here is all the point classified by category. It's very useful for working. Okay. MDT offers us, TCP point cloud editor offers us a lot of tools. We can make a cross-section, for example. Okay, we are going to make a cross-section quick profile like before in MDT, but only remain that that this profile are points. Okay, so depend on the density of the point of each point cloud. For example, right now, if we select the bandwidth, we can see different point or not. For example, if we have a very high density, a very low density, we need to make bigger bandwidth to see the points with different density. Okay, we are going to activate the dense positive highest. Okay, and we can check the difference. Okay, here is 2 meters of the bandwidth, and it's very high to the very high density. Okay, with this information is very useful to detect some line that we can see in the plan view. Okay, due to that category, we can select the right category if we want. We select only the ground point, and here is. It's very useful to analyze the point cloud. And in the same guideline, we can make a cut to the different point cloud. We are going to make a cross section with this horizontal alignment, for the same horizontal alignment. Okay, we are going to make a cross section, both point clouds, okay, with the same width band, and here is open. We can move station by station and check all entities, for example, the cable of the electrical facilities, the tree, the street, etc. And right now we are going to import the cross section that we create in MDT before. And here is, we can combine all the information to analyze and compare with each other. Okay, and here is, if we make a zooming in this detail, we can see the difference. For example, the point cloud has very precise. This is the wall, this is slope, this is the well side. There are the different due to the precision of the survey work from all the points we took with the point cloud, the laser scanner. Okay, the median, the different line, the car park, the sidewalk, and the fence in the right side. And here is, we can import the CAD from the ZWCAD that we have. Okay, we can visualize the different brick line and compare in plant with the point cloud. Here is, if we make import of the CAD drawing, select the layer that we want, and make a zooming in the area that we want to focus. Here is the grid, here is the point cloud, and here is the brick line to analyze. Okay, we are going to show more layers, for example, the wheels, the asphalt, etc. And here is all the information. As I said before, there are some difference between the vertices of the polyline that we took in the survey work, and we need to make several vertices plus to adapt to the point cloud. Is better than the survey work because we take point so far. Okay, we need to edit some brick line to adapt to the point cloud. Okay, this is the curve, and we could adding point by point, or bien we can use we can draw directly 3D polyline, or maybe some point to choose some point, etc. Okay, if we make a change the category, we can hide all category and select only the point that we want to show. This point, the ground point that we change, we are going to export to ZWCAD by format RCS. Okay, and this new point cloud we are going to import in ZWCAD to make easy our work in this CAD platform. And here is, right now, this is the problem to see all the information with the 3ADC. Right now, we are going to attach the new point cloud only with the ground point. Okay, yeah, we are going to hide the rest of the point cloud, for example, hide, and here is. Okay, right now we can see very good all the brick line that we took in the field. If we can edit, because we can use the point cloud easier there isn't an obstacle like a trees or obstacle like a noise or something like that. Okay, we can edit point by point, or we can draw directly a 3D polyline, etc. And edit our surface, our brick line to create a new surface, to create a new map, etc. At the end, when we finish our map, we need to design our civil project engineer to solve one problem. In this case, we are going to create a pipe to cross under the strip, one pipe to drainage the river on the left in the lagoon. For example, here is one project to design by MDT, and we are going to analyze, for example, the facility or the existing pipe under the street. For example, there is a clearance there nearly 1 meter, so there isn't any problem to create this solution. Okay, we can analyze this part with regarding the strip. For example, create the cross section of our pipe with the strip, and we can make calculate the different volume report, to very useful to create, to analyze in our reports. Okay, and here is the different layer of the trench. Okay, and we can print in several formats, Excel or something like that, to include in different book of our quantity takeoff to analyze all the project. Okay, and then when we finish our civil project engineer design, we need to export that information TcpGPS to stake out this road in the field. No, for in this case, we are going to import our design. In this case, a road T1000. Okay, we can analyze or we can review the horizontal alignment or the vertical alignment to check the information. And I think the more important thing is to check the cross section that we are going to stake out. For example, here is the cross section that we can move station by station. Okay, check the subgrade section. Okay, check the each cross section station by station. Okay, with the natural terrain, the trench that we are going to stake out in the field, and we can show the graphical visualization or the numerical data like this. We are going to use some code, for example, the 80 code or the 139 code to see the bottom of the trench, or maybe the contact with the natural terrain. Here is. Right now, we are going to stake out that road. Choose the stake out. And here is. When we are in stake out, we select the station that we are going to stake out, and we are going to choose again the cross section and the offset by subgrade selection, the right side. Okay, if we can select graphically the code, for example, in this case, we are going to use the bottom of the trench. Okay, right now TcpGPS lead us to the point, to the right position of the point that we need to stake out to make a mark in the field. For example, we need to move to the station 20. Okay, 50 meters ahead. Okay, 71 centimeter. No, sorry, 1 meter. Well, we are moving to locus to target the right side. Okay, and in the elevation we need to down 4 meter 40 centimeter. Okay, we need to move to the right side to stake out the point, and the reference of the elevation is 4 meter 40 centimeter. Okay, at the end we need to make all the mark in the field. Bueno, I hope you liked our presentation and the workflow that we follow in using the different applications that developed Aplitop. under the umbrella that offers us ZWCAD 2024 to work easy with our application combines to facilitate our work in day by day, no? Bueno, I hope you like it.